Hello students, welcome to the Yupp Master Foundation program. Today we are going to take the very important topic for the 9th class students. So it was included the animated videos and well crafted PPTs. By using the modern teaching methods, we are going to deliver the subject in a different way. While you are feeling difficult to solve the problems, just you can watch the class and feel that how you are going to solve the problems, right. Let us have a look to solve the problems in 1D motion, that is kinematics in 1D motion. Let us see previous competitive examination problems based on 1D motion, right. We are going to take the model problems which have given in the previous competitive examinations. All right, let us go for the case. An object has been dropped from a particular height. Generally, first of all, you need to talk about that one object is at particular height. Yeah, okay, we are going to talk about this one. What type of energy does it possess? It is it possesses that energy that is going to be identified, right. Yeah, you can take that potential energy. Just you have to take this one, right. At a particular height, you are going to take that at particular height is going to be h. So its mass is going to be m units, and if you are taking that, its a potential energy is going to get that kinetic energy. So you can identify that case. It was reaching that as that velocity increases in the downward direction. Let us assume it was while it was approaching the ground, its velocity is going to be increasing, no doubt at all. After that, it is going to be bouncing back, V decreases. Please identify this. First of all, you are going to get that energy is going to be converted, all right. Its potential energy is going to be converted into kinetic energy. It was utilized in the form of kinetic energy, no doubt at all. Can you say that the velocity is going to be increases? After the first bounce, its velocity is going to be decreased, gradually it is going to be decreased. So let us assume in this case V1, in this case it is V2, right. So the relation you can take that is V1 is greater than V2. Sometimes you need to calculate that the factor loss in velocity is going to be identified that V2 by V1. Let us see that, yeah, that is the case we are going to derive. So the ball has been dropped from a particular height, yes, it is very clear. It has been started from the rest, it is going to be at rest position. You should remember that u is equal to 0, its initial velocity is going to be 0, is equal to 0, no doubt at all. That is very clear. It has been covered the distance that would be h, you can take that. So, it is going towards the earth. So, A has taken as plus G, it is very clear. Now, it is going to solve the problem. You have to get that loss in speed by the factor V2 by V1. So, one equation is there, you can take that. Just I will erase some part. Okay. All right, let us go for one important point regarding to this. We would like to take this energy, it is going to be kinetic energy. Yeah, it is going to get this one. Here mass remains same. Same, right. So, according to law of conservation of energy, we can write that potential energy is equal to kinetic energy. So, we can take that mgh half mv square. This is the case, we can take that. Very clear, we can write down this expression. We can use this expression for the problem solvation, that is you need to find out that loss in velocity. This is the first case, let us assume. This is the first case, dropping. Okay. So, after bouncing, what happened? Its speed is going to be different. All right. So, bouncing, that is you can take that equation after bouncing, it is going to be following that. We can take that mgh is equal to 1 by 2 m v2 square. We have to consider this v2 because we are going to take that v1 is greater than v2, because after bouncing its speed is going to be decreased, obviously its energy is going to be decreased, no doubt at all. What happens, some part of energy is going to be imparted to that ground, which has been transmitted. You should take that change in momentum will takes place. All right. So, we can solve the problems based on this one, very clear. Now, let us go for the problems. Yes, good. So, here it is going to be V2. You need to calculate that case, right. It is very clear, we can go for the problems. Let us see, right. A boy standing at the top of tower of 20-meter height, all right. Now, you have to take this one, drops a stone, assume that J is going to be 10 meter per second square. The velocity with which it hits the ground, that is a case we have to solve this problem. Write down. Let us take the given data, top of a tower, it is going to be ground. So, the stone has been dropped, this is the stone, let us assume that u is equal to 0. What they have given 20-meter height, you have to take that 20 meter height, that is very clear. 20 meter. What they are going to ask you? The velocity with which it hits the ground. Yeah, it has been. We are going to take that. That is going to be V question mark. Just you have to apply that concept. Sometimes they may ask you what is the loss after the bounce, after the first bounce. Let us, if it is stone, it's okay. Otherwise, if he has taken that one football and tennis ball, sometimes it is going to bounce back. At the time, you need to calculate that loss in the velocity, and also you can identify. So here the stone, it has been rested on the ground after the fall, right? Yeah, you can take that. Initial velocity is going to be 0. This is going to be height. We are going to take the equations of motion which is suitable for this problem. Let us see, right? We can take that equation, right? V square minus u square is equal to 2as, right? Here we are going to take that s is equal to h, that is 20 meter, no doubt at all, and a is equal to plus g, that is 10 meter per second square, all right. And we have to consider u is equal to 0, that is also considered, u is equal to 0, right. Now you can substitute that. V is going to be question mark, therefore v square minus 0 square is equal to 2 into 10 into, that is, you can take units, yeah, later you can take that units, no doubt at all, that is of that is 20. While you are going to consider that meter per second square and meter per second. Very clear? Now, sorry, it is going to be meter only. Yeah. Okay, you will take that v square is equal to this is the problem, just you can see, right, that is 2 into 10 into 20, that is meter square per second square. It is very clear. Now you can solve this problem easily. You will find out that, therefore v is equal to, that is root of 2 into 10 into 20 meter per second. Yeah, you are going to take that, right? You will take that, it is going to be root of 400. Yeah, you will take that meter per second. Easily you will find out that root 400, that is root 2 root 100, root 4 root 100, 2 into 10, that is 20. Let us see that 20 meter per second is going to be answer, very clear, right. So, in the same problem they are going to ask that loss in velocity, easily you will find out that after the first bounce, right. Let us go for another one. Two cars P and Q start from a point at the same time in a straight line. It is very clear, the given problem is related to distance covered by the car is the function of time, all right. As the time increases, what happened? the distance covered by that car is also increases. Very clear, no doubt at all. So, at the same time, if you are going to take that, they are in the straight line. Yeah, they are in the straight line, that is 1D motion, right. What they are going to ask that, if they have been started from a one point, after what time they are going to meet, that is very clear. At what time they are going to meet that, yeah, it is very clear. So, they have given that position in the given problem, just you have to take that in order to estimate this one. This is the case we are going to take that, yeah, x axis, let us assume it is moving on x axis. So, you can write it as a function that is going to be time t. Yeah, distance has been expressed, that is you can write down at plus bt square. It has been written, that is distance covered. Yes, it has been written as the function of first one, that is I am going to write x of t is equal to at plus bt square. This is the first one. All right, let us take that another one, right, second one, which has been taken, right, that is x of t, that is ft minus t square. All right, it is very clear. We are going to take that x axis. So, we have taken the two incidents, that is the first one and second one. Yeah, they have been started. They are going to represent as xp. They are going to represent it by q. Let us take that q. It is very clear. So, the rate of change of position that gives the velocity, you can identify that displacement has takes place, that is going to be expressed in terms of differentiation. It is very clear. Now, finally, we are going to take that they have been started, first one and second one. Where they will meet? They are going to meet at one point, just you are going to identify this, all right. But they have given the information, the distance travelled by the car P and car Q was in the function of time, in the form of one function, that is in time, where A and B are constants, F is also constant. We can take this, is very clear, we are going to express that. Now, you are going to take that differentiation, we are going to take that differentiation, that is rate of change of, you are going to take that rate of change of position, that is you can identify that you are going to take that x is the position coordinate, x has been expressed in terms of t, that is x is equal to x of t for the first car, that is at plus bt square. This is also given, right. You are going to take that velocity, the position has given that, very clear. Now, you will find out that velocity is equal to d by dt of x of t p. All right, it's very clear. Rate of change of position, rate of change of position. Very clear, rate of change of position. So, with respect to the time, its position is going to be changed, right. Now, you can take that for first car and second car, that is P and Q, right. We can easily solve this problem by taking some space, we can apply that, right, right, okay. Let us solve this problem. When did they meet? You have to equate that the velocity of the first car and the second car. First of all, you need to find out that velocity of that first car. You can take that, yeah, for car P, position is going to be identified that x of t, that is at plus bt square. Okay, we will use this space, right. Now, you will find out that d by dt of x of p in t, that is equal to, you can write a plus 2bt, very clear. So, if you want, just I can write here to have the clarity, that is, yeah, you are going to write down here, that is d by dt of at plus bt square. So, a into d by dt of t plus b into, very clear. Now, you have that one formula for the differentiation. It is better to remember, yeah, d by dt of t power n, where n stands for 1 or 2 or 3, whatever it may be, just you have to take that, that is equal to n into t power n minus 1. This is the general notation. In the place of n, just if you want to get that, if n is equal to 1, let us take that n is equal to 2, it is better. Therefore, d by dt of t power 2, that is equal to 2 into t power 2 minus 1, 2 minus 1, that is 2t power 1. So, 2t, like that we can apply, this is the same case. Therefore, a into 1, yeah, plus b into 2t, this is v xp. All right, this is the first one. For second car, just you have to take this one. Yeah, we are going to take for the second car also, easily we will find out that, right. For second car, that is car Q. So, velocity is going to be taken, that is d by dt of that is x q t. Just you have to substitute this one, this is the case, that is d by dt of f t minus t square. It is going to be splitted d by dt of f t minus d by dt of t square. very clear, right. It is going to be f minus 2t. All right, this is equation number 2. You should compare both equation 1 and 2, easily you will find out the time, at what time they are going to meet, that is the question. So, this is V x q, right. Now, you have to compare compare equation 1 and 2, that is V x p is equal to V x q. So, it implies a plus 2 b t is equal to is equal to f minus 2t, right. You will take that, easily you will write down 2 b t plus 2t is equal to f minus a. Therefore, t 2t into b plus 1 is equal to f minus a. Easily you will find out that final value from this expression, easily you will find out that. Yeah, if you are going to take that final result, that is t is equal to f minus a by 2 into b plus 1, that is the result what we have been obtained. Let us see. Oh, I think this one is going to be matched with the answer, f minus a, that is 2 into b plus 1 or 1 plus b, okay, it is clear. This is the correct answer. By this time they are going to meet. This is a very simple approach, we can solve the problem. It is very clear. I hope so you are going to have that good observation. In this way we are going to take number of steps to solve the problem. If they have given in terms of that expression, it is very clear that the position of a car has been expressed in terms of the at plus bt square. Position has been expressed in terms of in the form of a function, that is with respect to some constant and time. So, the position of the particle can be expressed as a function of time, as the summation that we have taken, that is at plus bt square, here ft minus t square. It is very clear, right. Let us go for another problem, right. So, the motion of a particle along a straight line they have given. So, the motion of a particle has been described by a function, simply x is equal to this one, right, where x is in meter. So, the position of a particle has been expressed in terms of the function of time, right, that is 8 plus 12t minus t cube, right. What they are going to ask you? The retardation of the particle when its velocity becomes 0. You are going to get that retardation, it is nothing but the acceleration is going to be negative, it is very clear. Just you are going to solve this problem. All right, while you are solving this problem, just you have to write down that position of a particle that is x is equal to 8 plus 12t minus t cube. Very clear. The rate of change of position that gives the velocity, right. Rate of change of position. Right, is equal to velocity. Just we are going to take that rate of change of position that gives, right. You can take that d by dt of x that is equal to v. All right. Now, just you have to substitute, let it be equation 1 and 2. From 1 and 2 you can obtain that v, it is very clear. Let use the space, okay, we can use this space to this extent, right. Now, you can take that d by dt of 8 plus 12t plus, yeah, minus t cube, that is equal to v, no doubt at all. You are going to take this one, right. You are going to get, this is a constant, that is 12 minus 3t square, that is equal to v. Its velocity becomes 0. If v is equal to 0, v is equal to 0, then 12 minus 3t square is equal to 0. 12 is equal to 3t square. So, you will find out that 4 is equal to t square, t is equal to 2 seconds, just you will find out this. It is very clear, they have given the condition that velocity is equal to 0. Yeah. While you are going to consider that retardation, yeah, you are going to calculate from the time t is equal to 2 seconds, right. And you know that, yeah, acceleration, just you will take that is equal to d by is equal to that can be calculated d by dt of v. Very clear, right. So, you will use this formula, right. We are going to take that, we will use that of, therefore, a is equal to d by dt of, what about v? 12 minus 3t square. Yes, we will erase. Yeah, we will follow this, right. We can use some portion. Very clear that we will use the limited space, that is what I am going to erase some part, please follow that. Right. Now, we are going to take that acceleration is equal to rate of change of velocity, rate of change of velocity. So, we will take that acceleration. We have obtained that velocity as the function of time. Yes, this one. Yeah, we can apply that differentiation with respect to the time. It's very easy. So, that is equal to d by dt of v, all right. We can follow this one, right. It is going to be d by dt of 12 minus 3t square, right. We will find out that minus 6t, A is equal to minus 6t, right. What is your aim? The retardation of the particle when the velocity becomes 0. When the velocity becomes 0 at t is equal to 2 seconds, that is, yeah, the velocity becomes 0 at t is equal to 2 seconds, it is very clear. Therefore, retardation at t is equal to 2 seconds, that is equal to minus 6 into 2, that is minus 12 meter per second square, it is very clear, all right. While you are going to take that, this is the case, we are following that, okay. Easily we will solve this problem. This is an interlinked problem. First of all, you need to find out that velocity from the given function. After that, you need to apply that condition, the velocity is 0, at what time you need to take this one. This is very clear. Let us check that answer which is going to be matching with that. So, 12 meter per second square, 12 meters second square, but the negative sign that indicates that retardation. Yeah, we can take this one. Yeah, no need to consider, but they have mentioned that retardation, that is going to be followed that negative sign, that is minus 12 meter per second square. Yeah, it is very clear. In this way we can solve the problems. These are interlinked problems. To solve this kind of problems, we have to take that rate of change, that is rate of change that includes with respect to the time. The parameter changes. What the parameter? First one is the position, it will changes. Second one, velocity changes. So, the change in velocity with respect to the time, that gives the change in velocity with respect to the time, that gives the acceleration. It is very clear. It is going to be negative, just it has been considered retardation. All right. So, let us go for another one. Easily we will solve this problem. Let us see, the particle covers half of its total distance with the speed v1, right, v1, and the rest of distance with the speed v2. Its average speed during the complete journey. Easily we will solve this problem. What you have to find out that its average speed, very clear. Just take that one simple diagram and just you will solve this problem easily. That is half of journey, it is going to be, yeah, d by 2 v1 v2. So, the total distance is going to be d. In this case you have to solve this problem, that is v average is equal to total distance by d by 2 with v1 plus d by 2 with v2. So, finally, you will get that 2 v1 v2 by v1 plus v2. Let us see the answer. So, this is going to be the answer. It is very clear. In this way we can solve any kind of the problems. Thank you very much.